All of you, welcome. What is our present today's class? Boilers. Okay. This is a typical structure for boiler. Boys, are all you seeing? Slide. Hello. Boys, are you seeing? Vinay Kumar.
Sir.
Slide का display అవుతున్నాయి మీకు అక్కడ
Sir.
కాలేదా వీడియో ఆన్ చేయటమా ఓకే వినిపిస్తున్నాయా స్లైడ్ కనపడుతుందా టిపికల్ కమర్షియల్ బాయిలర్ ఎనీవన్ ఎవరికి కనిపించట్లేదా
కనిపిస్తుంది సార్
ఓకే రైట్ మీతో వాళ్ళంతా ఫాలో కండి దిస్ ఇస్ ది typical commercial boiler. If you see the textbooks that the schematic diagram says are differ from practical boilers. Okay, next class, next slide. We are seeing on the slide which indicates the definition. Okay, a steam boiler is a closed vessel generally made of steel in which water is heated by some source of heat produced by combustion of fuel and ultimately to generate the steam. A steam produced may be supplied at low pressure for industrial process work in cotton mills, sugar industries, etc., and for producing hot water which can be used for heating installations at much low pressure. Steam boiler should have minimum capacity of containing 10 liters of water logically, and its minimum working pressure should be 3.4 kg of centimeter square. Understand? Steam boiler or simply a boiler is a closed vessel. Generally, that vessel is made of steel in which water is heated by some source of heat. Generally, how can we produce this heat by burning of the fuel or combustion of the fuel? This heat, generated heat, used to produce the steam. Understand? As the heat is supplied to the boiler, because of this heat, steam raises water. Temperature will increases, then the saturation point. Once the temperature crosses the saturation point, evaporation starts. Okay, water evaporated. Okay, means steam generation starts. Okay, this is the a simple device which produces the steam. Okay, the produced steam may be low pressure steam or medium pressure steam or high pressure steam or critical pressure steam or super critical pressure steam. Understand? In this way we can produce the steam, but the minimum capacity must be volume of the boiler is 10 liters of water minimum. In domestic areas also, for domestic water heating, people will use boilers. Okay, so minimum quantity of boiler is 10 liters and the pressure produced by it is 3.4 kg per centimeter square. And next slide. Okay, a steam is, are you seeing the picture? Steam is the gas formed when water passes from the liquid to the gaseous state. At the molecular level, in this, when H2O molecules manage to break down free from the bonds, okay, keeping them together in liquid water, H2O molecules are constantly being joined together and separated. As the water molecules are heated, however, the bonds connecting to the molecules start breaking more rapidly than they can form. Okay. Eventually, when enough heat is supplied, some molecules will break free. These free molecules from the transparent gas we know as steam, or more specifically dry steam. Steam is used in a wide range of industries. Common applications for steam are, for example, steam heated processing plants and factories, and steam driven turbines in electric power plants. But these uses of steam in industry extended far beyond this. Okay, main aim of the steam is produce the electricity. Okay, come from the next class, next slide. Say we are seeing the water is evaporated from the beaker. Understand? We are taking certain water in a glass beaker, and from bottom side we are heating it by burning the fuel. Understand? So as the water is continuously heating, its temperature increases. Understand? Once the temperature crosses 100 degrees centigrade, evaporation will takes places. Understand? The smoky shade represents the steam. Understand? In boilers, that steam dome is covered and attached with one pressure gauge. Okay, pressure indicator. Pressure gauge is the device which indicates the generated pressure inside the boiler. Once the steam reaches to the required pressure, then the steam is allowed to flow through the turbine and expands over the turbine blades, and production of work done will takes places. Okay, next slide. You're seeing a slide classifications of boiler. Classifications of boiler. Okay, there are certain criterias. What are the criteria? Subject point of view. Okay, first one, horizontal, vertical, and inclined. So what is the subject point of view? According to the axis of the boiler. According to the axis of the boiler, we can then classify them into horizontal, vertical, and inclined boilers. Okay. According to its usage, these are called as stationary boiler. Okay, portable boiler, and marine boilers. Stationary boilers is a big boilers. We cannot move here and there once after they commissioned into service. Okay, the power plants, big industries, these boilers are erected and fixed to the foundation. Okay, with help of a strong foundation boards. Understand? And the portable boilers we can move here and there. Understand? Marine boilers. These marine boilers are the boilers used for navy ships. Okay, and steams, big cargo ships. Okay, the boilers are called as marine boilers. According to the structure through which water is flowing and the gases is flowing, the boilers are classified into water tube boilers and fire tube boilers. Fundamental difference. Inside the tubes, if water is flowing, then that boiler is called as a water tube boilers. Okay, over the water tube boilers, hot gases will flows. As the hot gases is flowing, this water presented inside the tubes will absorb the heat, and once the temperature crosses the saturation point, evaporation will take places, and produced steam is supplied to the application point, and steam issues through a nozzle and generates the power by expanding over the turbine blades. And fire tube boilers. What is meant by fire tube boilers? If hot gases or flames are flowing through the uh, boilers, hot gases after burning, the hot gases will be produced. If these hot gases flows through the tubes, then this type of boiler is called as fire tube boilers. Fire tube boilers. See, by seeing the name itself, we can say what type of boiler it is. For example, what is your idea on water tube boiler? If anyone asks. So water tube boiler is a boiler through which we can generate the steam. In combustion chamber, tubes are arranged, okay, at the top side of the combustion chamber. Once the burning of the fuel takes place, hot gases flows over the tubes. Okay, the tubes through which water is flowing. Okay, so because of the temperature difference, water presented in the tubes will be evaporated, evaporated, and production of steam will takes places. And what is your idea on the fire tube boilers? If anyone asks, fire tube is boiler is a boiler in which hot gases will flow through the tubes, and over the tubes water will be presented. As the hot gases flows through the tubes, because of the temperature difference, heat will be transferred from hot gases to the water presented outside of the tube surfaces. So this will increases the temperature, and the formation of the steam is takes places. But this is the thing. And according to the number of tubes presented in the boiler, we can classify them as single tube boiler and multi-tube boiler. Okay, according to the firing nature of the boilers, firing nature presented in the combustion chamber, they can classify them as internally fired boilers and externally fired boilers. See, internally fired boilers means firing hot gases are flowing internally. So internally fired boilers are nothing but fire tube boilers. Okay, fire tube boilers. And externally fired boilers, over the boiler tubes, gases are circulating. Okay, through the tubes, water will be circulated. So externally fired boilers are nothing but water tube boilers. This is the thing. Internally fired boilers means fire tube boilers. This is the fundamental difference we have to understand. And one more classification is there, subject to point of view. Naturally circulated and forced circulated boilers. See, this is by the circulation of water through the tubes. In I think 8th class physics, we had studied the buoyancy effects. Understand? Force of buoyancy. Okay, right there. What is meant by force of buoyancy? For example, there is a temperature difference. It causes density difference. This density difference causes the induction of convection currents. This creates induction of the force of buoyancy. Understand? This force of buoyancy makes the hot substances, liquids, to move or climb slightly upward direction. Understand? Slightly inclined pipes. Understand? Through inclined pipes, water will slowly moves up or rises up. Understand? This is the phenomena of natural circulation. Natural circulation is absolutely by the heating of the gases. Understand? Okay. If any boiler is employing that concept for circulation of water, that is called as a naturally circulated boiler. Understand? If you want to have a fast circulation of water and fast production of the steam, we will use pumps. Okay. If any boiler, if that type of arrangement is there, that boiler are called as forced circulated boilers. That means by using pumps, we are forcibly pumping the water to circulate through the tubes. That is why we are calling them as forced circulation boilers. Understand? And next point of view, source of heat. Source of heat. A solid fuel or liquid fuel or gaseous fuel or electrical and nuclear energy. Irrespective of the uh, fuel nature, our aim is to produce the heat by the combustion of the fuel. And lastly, according to the pressure, they are classified into following types: low pressure, medium pressure, high pressure. After high pressure, we can also list two types. What is them? Critical pressure boilers and supercritical pressure boilers. Okay, this is the certain information regarding the classification of the boilers. Let us see the brief information about water tube boilers. Water tube boilers. It is a boiler in which water is present inside the tubes. Water is presented inside the tubes and the hard flue gases surround the tubes. Since water is present inside the tubes, hence these boilers are called as water tube boilers. High pressure steam is produced by these boilers. The pressure of the steam is about 165 bar. 165 bar. These boilers falls under the category of high pressure boilers. Water tube boilers are high pressure boilers. The steam generation rate in water tube boiler is very high. This is approximately 450 tons. 450 tons per hour. Okay, per 1 hour we can generate 450 tons of steam. And if for a given power, the floor area, the floor area required for the generation of steam is in this boiler is as less as 5 meters square per ton per hour. Okay, for a given power, the floor area required for the generation of steam is very much less. That is approximately 5 meters square area per ton per hour. So what we can say, the requirement of area per ton per hour is equal to 5 meters square area. Okay. If we if the increase the ton of generation of the steam, floor space also increases. The erection and the transportation is easy as its parts can be separated. Okay, this is the information regarding fire tube boilers. Okay. Um, Sorry, water tube boiler. Now see the fire tube boiler. It is a boiler in which hot gases are presented inside the tubes. Boys, are you seeing the letters on the slide? Anyone? Okay, in next class I will put a big slide. Okay, what is the structure of this fire tube or procedure in which fire tuber is producing the steam? It is a boiler in which the hot flue gases are present inside the tubes and the water surrounds these tubes. A fire tube is present inside the tubes, hence it is called as a fire tube boiler, right? As the hot gases are flowing through the tubes, that is why we are calling them as a fire tube boiler. The steam produced by these boilers has a pressure about 25 bar, and that is why they fall under the category of low pressure boilers. Low pressure boilers are called as fire tube boilers are called as low pressure boilers, as the steam produced by them is having less pressure. Okay, the steam generation rate in these boilers are low, approximately 9 tons per hour. Whereas water tube boilers, we can put 450 tons of steam per hour. For a given power, the floor area required for steam generation is more, and it is about 8 meters square per ton of per hour. Say, uh, for a given power, the required floor area is 8 meters square area per ton, whereas for fire tube water tube boilers, it is only 5 meters square. Erection and transportation of these boilers are not easy, and this is because of their parts cannot be separated. That is why transportation is a difficulty. If we talk about the efficiency, then the overall efficiency of fire tube boilers is about 75%. The direction of the water circulation is not well defined. Okay, and a different path is not provided because simply water is presented over the tubes. Through the tubes, hot gases are flowing. That is the thing. Operating cost of this boiler is very less, as the production steam is pressure is less. Quantity is also less. The bursting is less. The chances for explosion or bursting is less. The bursting produces greater risk to the damage of the boiler. Okay. If the boiler exposes, bursting takes places, it causes a greater risk to the boiler. But it is not suitable for the large power plants, being the produced steam pressure is less. So we cannot use this for a big application like power plants, thermal power plants for a generation of electricity cannot be achieved by using this boilers. Okay, this is the simple information. Once again, we will see the summary. This is the commercial boiler, typical commercial boiler. Okay, see, enter this is, and steam boiler is a closed vessel generally made of steel in which water is heated by some source of heat produced by the combustion of fluid, and steam is generate. Okay, it is the this is slide giving the information in what way the bonds in molecules of hydrogen and oxygen is disintegrating, okay, as the temperature is increasing. So once they disintegrated into molecules, the steam evaporation takes places. Okay, this is the phenomenon of the formation of steam, expressing it in a chemical lab. And this is the classification of the boilers: horizontal, vertical, inclined, according to the axis, according to its motion, stationary, portable, and marine boilers, according to the circulation of water through or over the tubes. They are called as water tube boilers and fire tube boilers. According to the number of tubes, they are calling as single tube and multi tube boilers. According to the place where the hot gases are firing is called internally fired, externally fired boilers. According to the circulation of water, they are called naturally circulated and forced circulated boilers. According to the source of heat by burning the, according to the source of fuel used, we are classifying solid fuel boiler, liquid fuel boiler, gaseous fuel boiler, like that. According to the produced pressure, they are calling them as a low pressure boiler, medium pressure boiler, and high pressure boilers. We are once again we let us discuss the fire tube boilers. In fire tube boiler, the hot gases flow and present in the flows inside the tubes, and the water surrounds these tubes. As the fire is present inside the tubes, it is called as the fire tubes. Steam produced by these boilers has a pressure of about 25 bar, and that is why they fall under the category of low pressure boilers. The steam generation rate in this boiler is low, it's only 9 tons per hour. The erection and transportation of these boilers are not easy, and this is because their parts cannot be separated. Okay, as we talk about the efficiency, this efficiency is 75%. Okay, the direction of water circulation is not well defined, and the operating cost of this boiler is low. The bursting chances are less. If the bursting takes places, it causes the severe damage to the boiler, and it is not suitable for large power stations, as it is producing the low pressure steam. And next one, water tube boilers. It is a boiler in which water is present inside the tubes and the hard flow gases surrounds the tubes. Since the water is present inside the tubes, hence these tubes are called as water tube boilers. High pressure steam is produced by these boilers. The pressure of the steam is about 165 bar, and these boilers fall under the category of high pressure boilers. The steam generation rate in water tube boiler is high, and so 450 tons per hour. For a given power, the floor area required for the generation of steam is in this boiler is less. There is a 5 meter square area per a ton per hour. The erection and the transportation problem is easy, as the parts can be separated. Okay, in next class we will discuss the remaining things elaborately. Okay, boys. Now thank you very much. You can leave. Tomorrow we will meet you again. Okay, I will mention the time tomorrow. Okay. Thank you. Thank you. You can leave now, please.